Good afternoon, everyone. Today we're going to do an example of calculating the surface area of this rectangular-based pyramid, okay? So what we're given is the vertical height from the apex of the pyramid down to the very center, and we're given the dimensions of the base, okay? So what we don't know are the slant heights, right? So let's call this slant height S1, I'll make a note. Slant height number 1. And then of course, we need the slant height of this forward-facing triangle. A bit tricky to draw, but something like that. And we'll call this one S2. Again, for slant height number 2. Okay? So now, we know we have a rectangle as the base, and the area of the rectangle is length times width. And we know that we have two sets of two identical triangles forming the lateral area of our pyramid. And so we need this slant height to get the two side triangles that are identical, and also the slant height for this forward-facing triangle, because we know that the forward and the backwards triangle are also identical. And so what we need to do is, to find those slant heights, we need to construct right-angle triangles, right? So we can use the Pythagorean theorem. That's often the course of action we're going to like. And so if we go down the vertical height of our pyramid, which we know to be 12 feet, we can kind of see a nice right-angle triangle, if you can picture that, being formed, where slant 2 is the hypotenuse. We have the vertical height as one side, and we have this bottom side line as the bottom side. And let's go ahead and draw that more clearly. So if we go ahead and look for slant 2 first, just because it's facing us, we can kind of draw this right angle triangle like that. This is the one that's coming out of the board at us. And so S2 would be its hypotenuse. The vertical height, H, would be the vertical side, obviously. And now this bottom side length, right, we're going from the center of the pyramid over to the edge. And so this bottom side length is going to be exactly half of our side length. And so half of 8 feet is clearly 4 feet, okay? And that acts as the bottom side length, so now we have a nice right angle triangle where we know the two lengths of the legs, and so we can find the hypotenuse using the Pythagorean theorem. And so let's go ahead and do that. We're going to do that. Let's do, so we have S2 labeled as our second slant, and so let's say S2 squared is equal to 12 squared plus 4 squared. Again, this is something you've seen for the last few years, so you just follow through. S2 squared is equal to 144 plus 16, so S2 squared is equal to 160, and so S2 is the square root of 160, right? Taking the inverse of the square means taking the square root of both sides, holding true to our algebra, and so we get an approximate value for S2 of that'll be around 12.6. Whoopsies, I'm not French here. 12.6 roughly. Let's check that. If you want to check that at home, please feel free. We have square root of 160, 12.649. So 649 rounded to the nearest decimal place. Let's keep that as 12.6. So we have our first slant height for over here being 12.6, our units are feet, right? Now we're going to have to do something very similar for our side triangles for our S1, our first slant height. So using a similar approach, this one is a bit easier to draw. Since we have the vertical height going straight down the very center of the pyramid, this one's easier to draw a nice right angle triangle where we have the vertical height of 12. We again have this bottom side length. Since we're going from the center to the edge of the pyramid, we know that that's exactly half of this 12 feet. And so clearly we get half of 12 being 6 feet for this bottom side length, right? And so now, using the Pythagorean theorem once again, S1 being the hypotenuse of our right angle triangle, we have that the vertical height 12 squared plus 6 squared is equal to our hypotenuse S1 squared. And so 12 squared plus 6 squared. And let's run through that one again. So we have S1 squared is equal to 144 plus 36, and so S1 squared is equal to 180. And again, we want just S1, so the inverse of the square is the square root. So S1 is the square root of 180. And so we get an approximate value for S1 of 13 points. Again, using a calculator, feel free to check for yourself. We have the square root of 180 being 13.4, rounded to 1 decimal place. And let's stay consistent with 1 decimal place for consistency's sake. So we have that S1 is 13.4 feet, okay? And S2 again is 12.6 feet. Clean that up a bit. Okay. This is the hard part. We've done the hard work for this problem now. All we have left is to find the surface area of each of the surfaces and put it all together. But we've been doing that for a few years. So let's go ahead and do that. We have SA surface area is going to be the area of the base. Let's start off with the easiest surface. Length times width is 12 times 8. So we have 12 times 8 plus, I'll leave the units there until the very end just to make our calculations a bit cleaner. Next, let's do the two sides. So for each triangle, right, I'll remind you that the area of any triangle is base times height divided by 2. And so for the side triangles, we'll have a base length of 8. We'll have a height, a slant height for this triangle here of 13.4. And so we'll have 8 times 13.4 over 2, right? And we know that we have two identical triangles on the two sides of our pyramid. And so rather than adding that twice to catch both triangles, obviously we can just multiply by 2 to make our lives a bit easier. And then the same idea for the front triangle as well as the back. We have the base times over 2, so base is 12. The slant height for this triangle we found to be 12.6. So 12 times 12.6 over 2. And again, since we have the front and the back triangles being congruent triangles, identical, we can multiply those by 2. And now let's sum all of these areas up together. 12 times 8 gives us 96. Plus, here we have 2 times something divided by 2. And so clearly the 2's are going to cancel out nicely. This is going to give us 107.2. And then, once again, the 2's cancel out nicely. And so we have 12 times 12.6, which is 151.2, I believe. And now let's add those together to get our total surface area. And so we'll have 0.4, 1 plus 6, we have 4 and 1, and that's, so we have 354.4, and all of our dimensions were expressed in units of feet. We have surface area, which is 2-dimensional, and so we know that our units are square feet. And there we have it. Okay, I hope this helps. I hope this starts to make sense. And please leave a comment if you guys have any questions or suggestions, or if there's anything that I can clarify a bit better. Okay? Thanks for watching.